Thanks very much, everybody, for joining us today for this first part of our webinar series. So lots of you are probably joining us if you didn't attend our recent QC Roadshow. So no problem, we're going to cover off some of the core content in this series of webinars. So starting today with RIQAS report interpretation and troubleshooting. Okay. So for anyone who is not familiar with Randox, we are the UK's largest diagnostics company, and we are headquartered in Northern Ireland, which is part of the United Kingdom. We were established in 1982, and we have a number of facilities across the UK, Ireland, India, USA, which really boast good manufacturing facilities, and then of course our wider offices and distribution, which are spanning across 145 countries globally. We've got about 2,500 employees in Randox in total, and 800 of those are dedicated research and development scientists and engineers, so doing all the hard work to develop the products that we bring you here in Australia, New Zealand and wider. And across the Randox group, we have lots of different disciplines, lots of different areas. So we've got everything: reagents, QC, instruments, toxicology, point of care. Some of you might use some of these, some of you might only use one of them. And today we're going to be really specifically talking about quality control and RIQAS, which is our QAP program in Randox. So lots of you will be already somewhat familiar with RIQAS. You might have used it before in your laboratory. RIQAS just stands for Randox International Quality Assessment Scheme, and RIQAS is the world's largest EQA scheme. So we've got 72,000 laboratory participants across 139 countries. That's really important for your peer data, that you really get the value from your reports we're going to talk about today. And we've got 37 highly consolidated programs within RIQAS. So you've got lots of different options to cover your full test menu. Okay, so everyone, what we're going to do now is we're going to do just a little bit of a small interactive session. So if you've got a smartphone handy, if you open up your camera app and just scan over this QR code, we're just going to ask an anonymous question. So doesn't matter, there's no sort of right or wrong. It's just to get an understanding of what everybody's using their QAP for. So we'll give you a minute or two to load up your cameras and start participating in that.
Yeah. Yeah, so really the question is, because we're going to be talking about report interpretation and troubleshooting of EQA, we just wanted to get a gauge on what our audience today most hopes to gain from participating in external quality assessment. So it's a non-exhaustive list, but there's just a few here. So do you hope to gain or maintain ISO accreditation, gain an assessment of your bias, an assessment of your precision, or help you monitor your trends and shifts? So we'll give everyone a couple more seconds. All right, so thanks to those who participated. If you participated, you can see your anonymous answers on the screen now, but I'll just share with you some of the answers we received. So we had most people saying they hope to gain an assessment of bias, and definitely this is one of the main purposes of EQA and what we're really going to be talking about today. We had a couple of people say that they would like to gain or maintain their ISO 15189 accreditation, which definitely EQA is essential for maintaining your ISO accreditation. A couple of people saying an assessment of precision, and then the least amount of people saying monitor trends and shifts. So thanks everyone for participating, and we're going to be talking about all four of these aspects today, and hopefully you can get an insight on gaining all four of these aspects from your external quality assessment reports. So firstly, if you answered an assessment of precision, maybe you might be used to QAPs that do directly assess precision. So some QAPs we know assess precision by offering multiple of the exact same sample throughout the cycle. However, that might be a tricky one because EQA samples really should be blind samples, and by offering multiple of the same sample throughout the cycle, that kind of breaks the requirement. If a participant detects the same sample throughout the cycle, they might be able to easily identify that this is the replicate. That provides an opportunity for the falsification of results. Now, even if your lab might not do this, other labs might do this, and then that skews the peer data, making you think that maybe others are more precise than what you are. Precision can be assessed through coincidental, similar concentration throughout a cycle, which we'll talk about later. But I guess it's a metric that is best measured by IQC, and any measurement of precision in EQA should be considered in conjunction to IQC precision. And as we'll discuss later in a couple of our troubleshooting scenarios, just because you are precise in EQA and IQC, it doesn't mean you don't have a bias. So we have an example of this. So maybe you answered you most hope to gain or maintain your ISO 15189 accreditation. Definitely, it is a necessary component of quality control to gain and maintain your accreditation. And you'll find the statements on this in section 7.3 in the most recently updated ISO 15189 guidelines. But importantly, if you do hope to use EQA as a feature of your accreditation, it's essential to make sure your manufacturer of your EQA samples is an ISO IEC 17043 accredited proficiency testing provider. So these are an example of some of the certificates that you might be able to ask your proficiency testing provider for, just to show that they are an accredited body that is able to run these programs. However, as we'll talk about in some of our troubleshooting cases today, the focus of EQA should be on regular quality improvement, not just fulfilling the minimum requirements for accreditation, and it can get us in a sticky position when
40 people waiting on a different link. Sorry, guys. I just see Ashraf has mentioned 40 people waiting on a different link, but I'm not really sure what link that is because as far as I'm aware, we only have one. Okay. Let's see.
Right. Well, we'll keep going slowly.
Carry on anyway, Claudia.
Yeah,
I'll
that's
talk to
all right.
Ashraf and drop him a message here.
Okay. So yes, as I was saying, the focus of EQA should be on regular quality improvement, not just fulfilling the minimum requirements for accreditation. And it can get us in a sticky situation when we're just using EQA for accreditation. Perhaps the scheme isn't most appropriate to our needs and we're actually missing some sort of bias or trends and shifts. Okay. Maybe you also answered the ability to monitor shifts or trends. Perhaps you view EQA as a valuable tool to help you monitor your shifts and trends, which it is certainly able to achieve if you're monitoring your historical performance correctly. But often detection of shifts and trends in EQA can be viewed alongside and in combination with IQC historical data. And we've all might have seen this quote before from ISO 15189 at the very beginning of the section on quality control, which is section 7371. And it states that the laboratory shall have a procedure for monitoring the validity of results. The resulting data shall be recorded in such a way that trends and shifts are detectable, and where practicable, statistical techniques shall be applied to review the results. And this monitoring shall be planned and reviewed. And I think it's quite common to consider this ISO statement in the context of IQC, monitoring your trends and shifts in internal QC. However, this statement is at the very beginning of this section on quality control. It is neither referencing IQC or EQA, which is suggestive that it was an overall statement. So it is equally important to be actively searching for and identifying any trends and shifts that are happening in your QAP. And we do have a case study on this later about monitoring and detecting a trend and what you might be able to do to troubleshoot it from there. So perhaps you answered to gain an assessment of bias. So this is, in fact, the primary purpose of EQA, and it answers this question of, are my laboratory's results similar to other laboratories' results? It allows you to compare your test system to results from your method or instrument global peer group. Okay, so those were, I guess, the 4 options that we had in our little poll at the beginning. But to gain value from our EQA program, we must be able to understand and extract this information from each report to then interpret it and then narrow down the root cause. So how do I extract and interpret this information from my EQA reports? So we're going to be talking in the context here of RIQAS reports, but this is applicable to all types of EQA reports, not just RIQAS. Firstly, it requires understanding of all the sections, statistics and performance metrics in your report. And luckily, if you're a RIQAS participant, we have documents that go through RIQAS report interpretation and how to evaluate your performance. So this is available in the RIQAS brochure, which is publicly available online for you to have a look at whether you are a RIQAS participant or not. Or we also have an evaluation of performance guide, which is available to participants on RIQASnet from the homepage. But it's very handy if you break your EQA report down into sections and just look at everything one at a time. So we're going to go through the RIQAS report, but as I mentioned, applicable to all EQA reports. So this is the first section of RIQAS. It's broken up into 3 groups. It will give you first the all method group, then your method group, and then your instrument group. And for each group, these statistics are displayed. So N is showing you the number of results used to generate that mean. Mean is showing you your average result. Your CV is showing you your coefficient of variation. UM stands for uncertainty of the mean. SDPA stands for standard deviation for performance assessment. This is a metric that is quite unique to RIQAS. It is a measure of dispersal of results similar to SD and can be interpreted in the same way as SD. However, it takes into account our sample variability. So as part of our ISO accreditation as proficiency testing providers, we have to ensure that there's no potential for sample variability to influence your performance assessment. So that's what SDPA has done. And the final column is this EXC column, which stands for excluded results. And this shows you how many results in that category were identified as outliers, were then deactivated, and then were not used to generate the statistics. Section below in your RIQAS report will show you a summary of your results for this sample. So previously we only had peer group results, but here it will show your result denoted next to this little black triangle. And then below your result, it'll show the mean for comparison. Usually this little square on the left is coloured blue, and this means that you're being compared to your instrument and method specific mean. Sometimes when there aren't enough peers in your instrument group, we'll compare you to your method mean only. So we can compare you to your instrument group as long as there are at least 5 instruments enrolled for that analyte in this program. Across to the right, you'll see our 3 performance indicators. So the first one here is SDI. This is standard deviation index, and essentially it's telling us how many SDPAs, our adjusted standard deviations, does your lab's result deviate from the mean? And this assesses your accuracy to the group. So here we're looking for an SDI closest to 0, because a result exactly on 0 would mean that your lab has achieved the exact result of the group's mean. And here you can see in this example that this particular lab has achieved 34, which is almost identical to their mean for comparison. The second metric below is TS, which stands for target score, and this is RIQAS's unique scoring system. Target scores range from 10 to 120, with higher being better. It's generated by RIQAS and it factors in deviation of the lab's result to the mean and factors in an acceptable deviation for that test, which we name TDPA, Target Deviation for Performance Assessment. And the third metric is percent deviation. So this is a percent deviation, or what's sometimes called bias, from your lab's result to the mean result. Below each metric, you'll see the same metric again, but with RM next to it. And RM just stands for running mean. And this is a running mean of the last 10 samples for each of these performance metrics. As we saw in the last slide, you'll be judged for these 3 performance metrics on each report for each analyte. The results that fall within or less than plus or minus 2 SDI, results that have a target score greater than 50 and a percent deviation within the acceptable limits are deemed acceptable. Results that fall outside all 3 criteria will display a red triangle beside the parameter on the summary page of your report, and these are the ones that would warrant some review. Just below this, we have your peer group information in a histogram format. So it will follow the exact same colours as it did in the original section, the text section. So it'll show you green is your method group, blue is your instrument specific group, and the white is all peers within this program. And similar, again, your lab's result is denoted by the little black triangle at the bottom. So you can see where on the chart your lab is falling. This we have a section that's showing other method statistics to show the peer groups of alternative methods for that analyte. And on the right side of every RIQAS report will be 4 charts like this. So we'll show you what each of the charts look like. The first one here is a Levy-Jennings chart. So this simply just plots your performance over time, over the last 20 samples. On the bottom x-axis, it'll show us the sample number. So this goes from sample number 1 in your cycle right through till the next cycle because it includes the last 20 results. Across the top on the x-axis will show you your mean for comparison. So what was the mean for that particular sample? The second chart here is a target score chart. So this shows your target deviation for performance assessment at the top. This is that TDPA metric that I mentioned before. So TDPAs are set by RIQAS. They're established individually for every parameter, and they're designed to be fit-for-purpose performance intervals, taking into account all sources of potential variation. And they are based on historical RIQAS performance data that we've gathered over years. So some newer programs might not have this target scoring chart added to it. But in general, for the target score, if your percent deviation equals the total target deviation for performance assessment, your target score will be 50, which is the baseline acceptable limit. If your percent deviation is higher than the target deviation, your target score gets lower. But if your percent deviation is less than the target deviation, your target score gets higher. The next chart here I've put up is percent deviation by sample chart. So your result will be compared to preset acceptable limits. These limits are preset to RIQAS target deviation limits, but you could also change these if you like to biological variation or another national EQA acceptable limits of performance. The points within the white area means that they have fallen within the acceptable limits for this parameter. is the percent deviation by concentration chart. So this chart shows concentration of the previous 20 samples along the x-axis, and along the y-axis shows your percent deviation. So this chart can be particularly helpful to look for concentration-related biases over time. At the very end of your report, you'll receive this summary page. So it'll show you all the analytes that you're enrolled for and each of the performance metrics together with the running mean of your performance metrics. If all 3 performance indicators have failed in this sample, a red triangle will mark next to the parameter, notifying you that maybe that's a page that you should go spend more time looking at. Okay, so we have all this information now in our EQA reports. So I guess the next step is, what do we do with this information? How can we use it to troubleshoot real scenarios in our labs? So for our case study 1, this really relates to if you have precise internal QC, but potentially a bias. So we had a case a couple of years ago where VITROS users have reported very precise IQC and EQA performance, but it was very clear that the group had a positive bias compared with other methods for lithium. And you can see this very clearly here in the histogram. This blue bar chart here represents all of the VITROS users, and they're all quite precise, grouped together, but with a positive bias. So what did we do? We conducted a study with several partner laboratories and ortho. So patient samples were measured by the gold standard method, flame photometry, and the VITROS systems. And together with our partner laboratories, we realized that the VITROS had a 0.1 millimole per litre positive bias. And this can be quite substantial when you're looking at an analyte like lithium. So in conclusion, we've reported our findings back to ortho, and they adjusted their calibration values downwards over 2 slide generations. And you can see here the results that have moved everybody down into this middle area with all other peers. So another case study which talks about imprecision and being able to identify precision from EQA is this one here. So this particular lab had a running mean percent deviation of about 4%, which is within their target percent deviation. Their running mean standard deviation was below 2. So really, when you look at those first 2 metrics, you might think there's nothing wrong. But their running mean target score for the last 10 samples was below 50. So they knew they had a problem. And quite often when you see this combination, it does indicate that you have an imprecision problem, because your running mean percent deviation and your running mean standard deviation index will average out if you have the similar amount of samples either side of the mean. And you can see this really clearly by looking at the percent deviation chart. You can see the results are erratic. They're both above and below the 0 deviation line. So how could the laboratory troubleshoot this type of performance? For this type of troubleshooting, it's really important to be able to use the information in EQA reports together, so using multiple charts at the same time. So first, we reviewed their deviation by concentration chart to determine if the issue may be perhaps concentration-related bias. This isn't what their chart looked like, but I've just shown you an example of what you could expect if your bias was concentration-related, and why this particular chart can be so useful. So you can see here, if they had a chart looking like this, they would have had a positive bias at the low end of this assay. Or we looked for concentration-related imprecision. So maybe you have particular imprecision at some sort of concentration for this assay. Or the other alternative is just general imprecision. So it's not concentration-related at all. So I guess the key to this is as well is reviewing your IQC at a similar level if it is concentration related, or if it's not concentration related, reviewing IQC across multiple levels to see if you have the same imprecision. Okay, This case study here relates to EQA for accreditation, and I think this is a particularly interesting one because it took us quite a while to get to the bottom of this case. So this laboratory had a constant positive bias for alkaline phosphatase. We checked that their method and instrument registration was correct. We checked their IQC, it was all within reasonable limits. But you can see really clearly on their RIQAS reports, they have a constant positive bias. So how might you troubleshoot from here? Well, it took a bit of digging, and we asked the laboratory to recall any other necessary information about this particular assay, and we discovered that they had applied a 10% slope to this assay. Once we removed their 10% slope, we asked them to run a couple of RIQAS samples with their 10% slope removed, and it gave good accuracy with their peers again. But why had they introduced a slope initially? Well, it was because they had a bias on their national EQA scheme. So they introduced a slope to remove the bias that they were seeing with their national EQA scheme. They then reassigned their IQC target values, which meant that everything appeared okay on their national scheme, but really the root cause was still present. But why did they have a bias on their national EQA scheme? This also took a bit of digging to get to the bottom of, and this national EQA scheme was not on our side of the world. It was another national EQA scheme, but we found out that their sample was not commutable. It was an animal matrix sample, and it was not commutable to this particular assay. So this particular case study, I guess, really highlights the fact that it's not only important just to have EQA for your accreditation as a tick box activity, but there are differences that may occur between EQA schemes, and it really relies you to look into those differences. Okay, the next study is relating to detecting trends and shifts. So a particular laboratory who was assaying total protein had a negative bias that deteriorated but fixed itself every few months. They had identified this trend using a bi-weekly EQA program. So I guess that's another one of the benefits of using a more frequent EQA program. You're able to identify these trends and shifts that may be occurring in smaller timeframes. It's likely the causes we see of trends and shifts in EQA reports are reagent onboard stability deteriorating. So perhaps the manufacturer has quoted reagent onboard stability. However, this may not always be the case. Often when manufacturers quote onboard stability, the reagent has been worked up in absolute optimal conditions in their factory laboratory, not in a real lab. Secondly, calibration too infrequently. So we see results especially starting to drop off after less frequent calibrations than necessary. And then lastly, calibrated material stability. This can also deteriorate quicker than what it says on a manufacturer's kit insert. So those three things are very important to be doing some sort of validation work on yourselves, because we have seen it time and time again where what they quote on the manufacturer's kit insert isn't always what we find when you do some more digging. So this particular laboratory reviewed their calibration frequency and their calibrator open vial stability. They adjusted their calibration from every reagent lot change to every 15 days. And they also identified that the calibrator had lost stability. So now they make up and use fresh calibrator. So I guess protocols for determining a trend or shift in EQA are crucial. Unlike IQC, there are no multi-rules that flag when a trend or shift has developed. And we do give the general advice that 3 points in a row is a trend worth investigating. but it's not necessary to take corrective action from one point outside of 2 SDs. That type of situation can be watch and wait for your next EQA report, and then see if there's a further trend occurring in the same direction. This case study here discusses bias from a peer group. So we had a couple of labs a couple of years ago that came to us with this issue with their testosterone kits. And all of a sudden there was a little group of labs moving away from the general peer group lab. So I guess the first thing you'd need to ask in this troubleshooting scenario is, how far am I away from the original peer group? Am I alone away from the peer group, or are there several other peers with me in this sort of bimodal distribution? And this is what we found for this particular testosterone kit. So possible causes of this sort of bimodal distribution could be perhaps some of your labs in your peer group have a slope introduced, like that example earlier. Perhaps there's non-commutability to different lots of reagents, or in this case, what we found is that there was a new kit introduced in some parts of the world which hadn't yet made it to other parts of the world. So we were getting this bimodal distribution, even though they were using the same instrument, same manufacturer's reagent, it was different versions. And it was bioMérieux, so they brought out a new kit which was giving much lower results. So once we were notified of this, a separate method was set up for this new kit, and over time all users have moved to this new kit, and they've standardized themselves in this peer group. Another couple of issues that require troubleshooting, and we do see sometimes commonly, is this particular one here. So if we see a laboratory that's looking at their summary page at the back of their report, they have all of their, or most of their analytes flagged with the little red triangle to say that they have exceeded their 3 performance metrics. What might be wrong with this type of sample? And usually in these cases, it's a reconstitution error. And another good way to identify this is having a look at the percent deviation. So if there are percent deviations all at a similar magnitude in a similar direction, that's usually indicative of reconstitution error. If the percent deviations are flagged, but they're not similar, at a similar magnitude and in a similar direction, it could be that you've actually run the wrong sample. Some useful tools that we offer on monitoring EQA performance are these two here. So these are available to everyone. These are available in our RIQAS brochure, which you can find online. So the one here on the left is our checklist for monitoring EQA performance. So it can be really useful when you're investigating a particular poor performance. It just gives you a little checklist to go through, and allows you to think of perhaps a factor that you didn't think of previously. And similarly, there's a flowchart version of this as well. So we've talked about today how we can gain insights about our precision, about our trends and shifts, about our bias, and how it is definitely important to use EQA to maintain our accreditation, but the correct EQA to maintain our accreditation. But I guess assumptions that we make from EQA, assessments that we make from EQA, rely on assumptions about the sample and the program. To be able to draw these conclusions, we really rely that the samples and the programs are functioning in the way that they should. So firstly, to make these assessments, we should have a statistically significant peer group. Larger peer groups equals more statistically relevant data. Especially if there is a wide range of instruments and methods covered, so it can place you in the correct area of the overall peer group. Secondly is stable and commutable material. So EQA material, just like IQC material, should be of the same high quality. Human samples ideally free from interfering preservatives or stabilizers, which gives us then increased confidence that our performance and the conclusions we're drawing from our performance will mirror that of our patient samples. Thirdly is frequent reporting and rapid feedback. So to be able to draw these assessments and make corrective actions, we should have EQA that provides us with feedback rapidly to identify issues sooner, to take corrective action sooner, and cover all concentrations across the assay range sooner. So just a couple of features before we finish up on RIQAS, which directly relate to a couple of these points. So especially the global and statistical significant peer group point, RIQAS this year has had over 72,000 registrations across 139 countries. Many registrations, I'm sure, have come from Australia and New Zealand. I'm sure a couple of you are here today. Our samples are human samples. They're free from interfering preservatives or stabilizers. And in our cases of our immunoassay program and our urine program, these are actually 100% human samples. We have a rapid turnaround time, so it's usually 48 to 72 hours after the submission deadline, you will receive the report. You can register up to 5 analyzers per program. This is free of charge as long as you can run the tests with the amount of material we provide you in the kit. You can register up to 5 different analyzers. You can receive complimentary interlaboratory group reports, which allow you to compare affiliated laboratories in, say, if you have a network in your state or country. You'll receive participant certificates, which give you evidence of participation in a reputable EQA scheme. And we have local and HQ-based complementary support and troubleshooting services. So if you are ever having issues with a particular analyte in your RIQAS program, we do offer this complementary support and troubleshooting. We can sit down and go through these things like the checklist, maybe think of some aspects that we've heard before in other troubleshooting situations, and offer you any advice. Just to touch on the RIQAS programs that we offer this year. So these are all up here on the screen. I won't go through every one of them. As Anna mentioned, we now have 37 programs and growing because we have some new pilot programs this year. So the first of which will be blood typing. So quite a new area for us going into blood banks. Antipsychotic drugs. This will be another pilot program coming out later on in the year. The third is preeclampsia, so our SFLT1 and PLGF markers will be releasing in a RIQAS program. We've just recently released the IQC version, but the RIQAS will follow. And similarly, the xanthochromia program. So we've just released this in a IQC, but the RIQAS will follow later on this year. So you will receive notifications about each of these pilot programs. If you want to get involved, they are free to be involved in. You get full reports to see what other labs are performing like in these programs. They're usually 2 samples. And then it'll give us an opportunity to amend anything in these programs before we release them as a full program, likely in 2025. If you are interested in anything we mentioned today, report, troubleshooting, interpretation, or any programs, these are some local Randox contacts. You're welcome to contact the customer support.australia@randox.com office email for any inquiries, and someone will get back to you. And if you are in New Zealand watching today, here are your contacts on the screen. All right, so thanks everyone for joining. I hope you took away something useful out of today's session. If you would like to ask any questions, we can stay on for a little bit to answer any questions, or feel free to email us. This will also be made available as a recording. So you'll receive that in your emails shortly too. We look forward to having you again on another webinar shortly in the future. It won't be on RIQAS, it'll be based on perhaps IQC, and we're looking to do a couple of molecular focused webinars. So we look forward to seeing you then, and have a good afternoon.